right, today we are on our second section of notes for our unit. This one we are talking about rates and unit rates. So a rate is a ratio that compares two different, that's not how you spell different. Try again. Two different quantities. So for example, it might be something like 60 miles to 3 gallons. A unit rate is a rate with a denominator of 1. To change a unit or to change a rate to a unit rate, we divide the numerator by the denominator. So for the directions, it says express each rate as a unit rate, round to the nearest tenth when necessary. So before we get started, we have to talk about when you write a rate, you use the slash symbol, and it is read as per. Also, on this one, no label, and the answer is wrong. This is really important, especially because you're comparing two different quantities. So you have to label everything, and your label should have two parts to them. It should be whatever the label for the numerator was, per whatever the label for the denominator was. So for example, on this first one, when I did miles per gallon, if I was writing that as a unit rate, I would write miles per gallon. Okay, looking at number 1, 175 children in 5 classes. So first thing we're going to do is write a rate. So 175 over 5, so that's my ratio. And now I'm simply going to plug it into my calculator. 175 divided by 5 tells me that it is 35 kids per class. Moving on to number 3, 228 magazines in 4 boxes. First thing we're going to set up our ratio, 228 to 4. And now I'm going to make a unit rate out of this, so I'm going to put it in my calculator. 228 divided by 4 equals 57 magazines per box. Here's another one. 3½ cups of sugar for 5 1/4 cups of lemonade. Same thing, we're going to set up our rate or our ratio. 3½ cups of sugar for every 5 1/4 cups of lemonade. Same thing, you're going to put it into your calculator. 3½ divided by 5 1/4. And it should tell you that it is 2/3 cup of sugar per cups of lemonade. So really all you're doing is just dividing this in your calculator to get your unit rate. So go ahead and do 2, 4, and 6 on your own. Pause the video, do the problems. When you're finished, unpause the video and check your answers with mine to make sure that you've done it correctly. Okay, now that you've had a chance to do them, here we go. 3,000 marbles in 200 jars. 3,000 over 200. Dividing that in my calculator, I get it is 15 marbles per jar. And remember, if you do not put a label, it's wrong. Number 4, 138 cups of flour used in 46 dozen brownies. 138 over 46. Doing my division, I get that it is 3 cups of flour per dozen brownies. Number 6, last but not least on this, Ben walked for 8.5 minutes and covered 3/4 of a mile. We're going to do 8.5 minutes per 3/4 of a mile. So 8.5 divided by 3/4. Putting it into my calculator, I get that it is 11 1/3 minutes per miles. A couple of things about this one. Notice I did not leave this as an improper fraction. It has to be changed to a mixed number. If I had left it as an improper fraction, it would not have made sense to say that I walked 34 thirds minutes per mile. Like, that does not sound right, and it doesn't mean anything to somebody if you said it like that. So making sure that all of your improper fractions for these have to be changed to mixed numbers. It's very similar to a word problem. Like, it doesn't make sense in the context of the problem unless I'm saying it as a mixed number. So on these, if you have mixed numbers, you have to make them, or excuse me, if you have improper fractions, you have to make them into improper, or man, I cannot tonight. If you have improper fractions, you have to make them into mixed numbers. Also, noticing on the label, it is fine to abbreviate for some of them, but please make sure you are aware that the label for miles is MI. The label M is for meters. Those are different things, like completely different things. So make sure if you are abbreviating some of your distance labels that you are using the correct one. Okay, let's look at number 7 together. The table below shows the number of cupcakes and the number of cakes made by each of the 4 bakeries each day. Which bakery makes the most cupcakes per cake? So the first thing you're going to do is you're going to set up each one. It says cupcakes per cake. That means I want cupcakes over cakes. So I'm going to do 360 divided by 28. Then I'm going to do 400 divided by 35. 375 divided by 25, and then 385 divided by 30. So I now have a rate set up for each one, or the ratio set up for each one. Now I'm going to divide to get my unit rate. On these, when I divide them, I'm going to give 2 decimal places just at first, and then we'll talk about rounding. So for the first one, 360 divided by 28, I get 12 86/100. This is cupcakes per cake. 400 divided by 35, I get 11 43/100 cupcakes per cake. Then 375 divided by 25 gives me 15 cupcakes per cake, and that is per 1 cake. And then on my last one, I get 12 83/100 cupcakes per cake. That's per 1 cake again. Now, we are going to do some quick rounding on this. It says to round it to the nearest tenth when necessary. So on this one, this is approximately 12 9/10. Over here, we're at approximately 11 4/10. This one stays 15. And then on this one, we're going to round it to 12 8/10. So the question says, which one makes the most cupcakes per cake? The most cupcakes per cake would be this one right here, because they make 15 cupcakes per cake. That is the most. So then you would write a sentence that said something like, Tamira's treat shop bakes the most cupcakes per cake. All right, go ahead and try to do number 9 on your own. Make sure you are remembering what it's asking you. Notice it says who ran the fastest per mile. That does not mean the biggest unit rate. Think about time and running. The faster you run, the lower your time would be. So go ahead and do number 8 on your own, pausing the video, unpause the video, and check your answers with mine. Okay, now that you've had a chance to do it on your own, let's go ahead and do it together. So for Marcus, we're going to set up his rate, 105 over 13. When I divide it, I get 8 1/10 minutes per mile. For Joseph, I'm going to set up his rate. It is 153 divided by 18. When I divide that, I get 8 5/10 minutes per mile. Harper, I'm going to set up the rate. It is 176 minutes over 20 miles. That is 8 8/10 minutes per mile. And then last, I'm going to set up Nikki, 140 over 15. That is 12 8/10. Oh, excuse me. I was looking at the wrong thing. Ha. Try that again. That is 9 3/10 minutes per mile. And again, when we're talking about who ran the fastest, we are looking for the lowest time. So going through looking at the lowest time, it would appear to me that Marcus has the lowest time. So then I would write something like Marcus ran the fastest per mile. All right, go ahead and flip it over to the back. All right, now we're on the back. We are going to talk more about unit rates with price. Unit rate prices give the cost per 1 unit. This is especially helpful when comparison shopping in order to find the best deal. When finding a unit price, we always divide the price by the quantity. This is actually extremely helpful in the real world. I do this a lot when I'm grocery shopping. If I'm trying to figure out what I'm going to get the best deal for my money, I want to spend the least per unit price or per quantity because that gives me a better deal when I'm buying something. A couple of things that you should note on this, and jot this down please. Money always goes on top. When we are talking about unit prices, nobody says, or when you're buying gas, they say it's $2.63 or whatever per gallon. So the money always goes on the top when you're doing these. It's still set up the same way. So you're going to look through this and you're going to figure out where your money is. $19.20. That goes on the top of my rate. Over 6. To find the unit rate, it doesn't change. You're still doing the division. So I'm going to do $19.20 divided by 6. And it comes out to $3.20 per foot of ribbon. Now, a couple of things. When we're talking about money, money always has 2 decimal places. So please make sure when you're writing your answers, you're not writing 3 2/10 because nobody says that in money. They say $3.20. So again, money always has 2 decimal places, rounded correctly to the second decimal place. All right, looking at number 11. $1.44 for 12 pencils, so $1.44 is going to go on top over 12 pencils. Putting that in a calculator and doing the division, I get that it is going to cost me 12 cents per pencil. And the nice thing about this is when you're writing your labels, the money sign always goes up top. So that's a quick jot. And then per whatever it was. 13, 16 ounces of potato chips for $4.96. $4.96 goes on top. Over 16 ounces. Putting that in my calculator and doing the division, I get that it is 31 cents per ounce. Number 15, 15 boxes of tissues for $33.45. $33.45 is money, so it goes on top. Divided by 15, putting that in my calculator, I get that it is $2.23 per box. 17, 3/8 of a pound of fruit for $15. Same thing, money always goes on top. 15 over 3/8. Putting that into your calculator works just fine. 15 divided by 3/8. If you were going to do this out longhand, remember we don't divide by fractions, we multiply by the reciprocals, but since you're just putting it into your calculator, 15 divided by 3/8 should give you $40 per pound. I know that sounds crazy, but if you think about it and you're paying $15 for not even half a pound, that seems reasonable. All right, I would like you to do 10, 12, 14, 16, and 18 on your own. Pause the video, do the problems. When you're finished, go ahead and unpause the video and check them with me. Okay, now that you've had a chance to do them, here we go. $63.21 for 7 hours of work. That is $63.21 divided by 7 comes out to $9.03 per hour. $4.50 for $4.50 for 3 hot dogs. $4.50 goes on top, divided by 3. Remember, money is rounded to 2 decimal places, so this is $1.50 per hot dog. Remember, we're not writing 1 and 5/10. Money has 2 decimal places. Moving to 14, 9 ounces of dish soap for $1.71. So I'm going to do $1.71 divided by 9. That is 19 cents per ounce. Number 16, $1.95 for a pack of 5 pens. That's $1.95 divided by 5. Putting that in my calculator, I should get 39 cents per pen. And then last but not least, 2 1/5 feet of fabric for $3.30. $3.30 is our money, goes on top, divided by 2 1/5. Again, if you wanted to do this out longhand, you need to make it an improper fraction and then multiply by the reciprocal. But we have a calculator, so go ahead and just plug that in. $3.30 divided by 2 1/5. And you should get that it is $1.50 per foot of fabric. All right, last up is finding out which one is a better buy. So when we're talking about the better buy, the lower price of the object per object is going to be the better buy. So if you think about it, would I rather spend $15 for one book, or would I rather spend $13 for one book? So if it costs more money, it's not the better buy. You are looking for the lowest price per item to get the better buy. So we're actually going to start with number 20. Option A says 12 binders for $30, and option B says 7 binders for $16.80. The first thing we're going to do is you're going to find the unit rate for each one. So setting this one up, 30 divided by 12. And then down here, $16.80 divided by 7. Putting them into your calculator, 30 divided by 12 is $2.50 per binder. And then on the bottom one, $16.80 divided by 7 is $2.40 per binder. So if you are thinking about if you have to buy a lot of binders, you really want to spend the least amount of money per binder as possible. So the lower your unit price is per object, that is the better buy. So the less money you have to spend for the same object is the better buy. So for 20, you're just simply going to look at the unit rates, figure out which one is the better buy. It is a better buy to spend $2.40 per binder, so I'm simply going to check option B. Okay, let's do 21 together. Option A is 12 ounces for 60 cents, and option B is 20 ounces for 95 cents. So again, I'm going to set up my unit rates. So for the first one, I'm going to put 60 cents over 12. And then on the bottom one, I'm going to do 95 cents for 20. Now on this, make sure you're putting the money on the top. And then when you're doing it in your calculator, you're dividing 60 cents divided by 12 comes out exactly to 5 cents per ounce. And then in my second one, when I do 95 cents divided by 20, you're going to notice that it comes out to a decimal. So we're not going to actually round right now, because if you round it, you'll notice that it would still come out to 5 cents per ounce. So you're need to looking at these at their most raw form without rounding or anything like that. So looking at this one, it is exactly 5 cents per ounce. And then this next one, it's just a little bit less than 5 cents per ounce. So because it's a little bit less than 5 cents per ounce, that makes option B the better buy. So I'm going to check option B. All right, go back and do 19 and 22 on your own. Pause the video, do them on your own. And when you are finished, unpause the video and check your work with mine. Okay, going back to number 19, option A, $195 for 15 pizzas, setting up my rate. Dividing 195 divided by 15, I get it is $13 per pizza. And option B is $120 for 10 pizzas. Dividing that, I get that it is $12 per pizza. If I am shopping for pizzas, I would rather spend $12 for a pizza than $13 for a pizza. So option B is my better buy. And then moving down to number 22, setting up my rates, $1.80 for 3 apples. When I divide $1.80 by 3, I get that it is 60 cents per apple. Option B, $13.50 divided by 15 apples. I get that it is 90 cents per apple. If I'm buying apples, I would prefer to spend 60 cents on one apple than 90 cents on one apple. So on this one, option A is the better buy. Just a quick note on number 21, we've already done it, but you do have some like this in your homework. So make sure, like I said, you're comparing them in their unrounded raw forms before you figure out which one is the better buy. All right.